So once again, what we want to do with practice modeling these quadratics is use our calculators to help us investigate that data. So it says a player hits a tennis ball across the court and records the height of the ball at different times shown in the table. So go over to our table, go to edit. We're going to clear the data in L1 and L2. So again, in order to do that, you just go up to L1, go up to L2, hit clear. I'm going to enter that data. Part A says find a quadratic model for our data. So stat calc option 5. Calculate. Yeah.
Oh, my calculator just fell.
If you want to put it up in my charger up there, and then if you come back here, if you look, actually, like you too, Grace, find the ones that are yellow on top because they're the newer calculators. So if you grab one of the yellow ones, it will match my screen a little better. It's just not an LED screen. They're kind of like the boring screens. Okay, so it says use a model to estimate the height of the ball at 4 seconds. So 4 is our time is our X, our height was Y. So we're going to plug 4 into X. And we get 1.5, and again, that represents a height. So we want to be sure to include our units, which are feet. Okay, and then next we're going to go back. It says, what is the ball's max height? So that is the K value or the max of the path of the ball. So again, you have two choices. You can either find H and K the old way, which is negative B divided by 2A, or you could do it where we take this equation and we complete our square and rewrite it in vertex form. Or you can also do it by putting this equation in our graphing calculator. So I'm going to clear out y1 and y2. I'm going to enter that equation in my y1. I'm going to hit graph after I fix my window because my window is still on the previous data. So now I'm going to make my window 0 maybe to 10. And then 0 maybe to 15. And I see the pathway for the flight of the ball. Second, trace allows me to pick max as one of my options. And then move my cursor so that it is to the left of that height. So again, I'm predicting my max is going to be somewhere around here at 5.9 and 9.8. But I want to go to the left of it and to the right of it. And I see that the max occurs at 0.9999999, which is really 1 second, and is at a height of 6. Okay? So at t equals 1 second, the ball is 6 feet high. 6 feet is the ball's max height. And then it says, explain why the quadratic model only works up to 4.5 seconds. So if you again follow the flight in the path of the ball, it goes down through the curve here. So if you go to second trace and value, you can hit 4.5. And at 4.5 seconds, the ball is at a height of negative 0.125. So the reason that we can only look at the height of the ball between 0 and 4.5 is because after it hits right here at the 0, it's kind of like the ball hitting the ground. And we know that in actuality, the ball can't go into the ground. It's going to hit the ground and bounce back up unless it's a new no bounce ball, which they drop dead. They're very crazy. Okay, so why can't it go beyond 4.5 seconds? Because the ball would hit the ground and bounce. Okay, the table 3 shows the height of tides measured in Santa Monica Municipal Pier in California. Hours are measured from 0 to midnight. Find a quadratic model for the regression of this data. So again, we're just going to go to our calculator. We're going to go to Stat. We're going to go to Edit. I'm going to clear what's in there. Type in my new data. Get my quadratic regression. And again, if you want to store that equation in y1, first you need to make sure that your y1 is cleared. And second, you need to make sure that when you go to this, we hit alpha and trace and enter y1. So I have my quadratic model. I'm going to use it to predict the lowest tide height. So again, I'm going to go to y equals, my equation's in there. I'm going to hit graph. I'm going to change my x max because this is at time 11 to 24. So when is the lowest tide? That's going to be the opposite. So we've been doing maximums. This one is a minimum. So we're going to go to second trace. And I'm going to go down to option 3 for min. And again, you have to be for the left bound to the left of the min. Enter. For the right bound, I need to be to the right of the min. Enter. The guess doesn't matter. You can leave it on your bound. You don't actually have to move the cursor to guess. And I see that the minimum tide is 2.4879 feet. And occurs at 5.179 hours. When did it occur? So in terms of time, 5.179 hours is 5 hours after midnight. So that would be at 5, and then to get 0.179 into hours and minutes, you would multiply it by 60. So that would be about 11 minutes into 5 a.m. So it would occur at 5:11 a.m. Okay. So the remainder of your packet, it's not front and back. So what I want you to do is use the remainder of class time today to work through these problems. Work through the quadratic regression. Remember, the last page is just the keystrokes again. So you are doing problems 1 through 4 on the graphing calculators again. And then I just want you to kind of go back and work through writing a quadratic and parabolic and standard form. And again, you can use the calculator to get these answers. So you would put these into your list. This -4 would kind of be like an x1, y1, x2, y2, x3, y3. So you would put all the x's in L1 and all the y's in L2 in order. These 3 would be by hand. And like the warm-up we did yesterday.